Hi friends, welcome to my channel. I hope everyone is doing well. Today we are going to solve another very likable and very popular coding interview question. It's on Leetcode number 80, remove duplicates from sorted array 2. So this is another frequently asked question in interviews, asked many times by many companies. So make sure you watch this video until the end so you completely understand the logic as well as the Java solution to solve this coding problem. If you are new to this channel, please subscribe to this channel now. It really helps and supports this channel. Here we create videos to help others in their interviews and Java interviews. So let's start. Given an integer array num sorted in non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. Since it's impossible to change the length of the array in some languages, you must instead have the result to be placed in the first part of the array nums. Okay, so they are saying that whatever is the result, you can just place that in the first part of the array, and you have to do it is in place. So what it means is you cannot use any other data structures basically to hold that data. Okay, and return k after placing the final result in the first k slots of nums. Okay, so more formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It doesn't matter what you leave beyond the first k elements. Do not allocate extra space for another array. You must do this by modifying input array in place with O1 extra memory. That's what they are saying. O1 extra memory means you will not use anything else basically, right? So we'll go through some examples. Nums.length will be between 1 to 3 into 10 raised to 4, and the numbers will range between minus 10 raised to 4 to plus 10 raised to 4 inclusive. And nums is a sorted array, okay, and it's a non-decreasing order. So let's take a look at this first example. So you can see that the one coming 3 times, so maximum 2 times you can have that number. That's what the problem says, right? So this one third time you can remove it, and then you can just place the array after you remove that one, right? So the last element will be just left blank, or you can leave it whatever, it doesn't matter there basically. So that's what they are saying, right? And k means how many numbers are left actually now after you remove that third, like the third numbers basically, right? The numbers which are coming more than 2 times basically, the same number, right? So there are 5 such numbers now, so that's why you have to return 5, and the nums array should be modified like this. Okay, so let's take this example over here. So this is the example, the second one. So now you can see that what we are allowed to do, we are allowed to keep same number maximum 2 times basically, they are saying, right? 2 times. You can see here that each unique element appears at most twice, right? At most twice. Okay, so now 0 is appearing at most twice, so no problem. 1 is appearing 4 times, so I have to only keep the first 2, right? This one we have to delete basically. Okay, 2 and 3 we can keep as it is, right? And this remaining last 2 elements, it doesn't matter whatever you leave there basically, right? So how many total numbers are left now? 7. So that's what you will have to return here, correct? And you will have to update the array in such a way that this ones you have to remove from that array basically, correct? Because maximum 2 times you can keep that number, right? So now 1 is coming 4 times, it means that you have to remove that 1 2 times basically, correct? So this is what the problem statement says. So I hope the problem statement is pretty clear, and you cannot use any hash set or a hash, nothing. You cannot use anything basically. You have to do it is in place basically, right? That's what they are saying. That is the very important part of this question, that you must do this by modifying the input array in place with O1 extra memory. Very important. Okay, but now how can we do the in place, right? If we would have option to use uh, other data structure, we could have just used set or some other hash map or frequency map or something, right? But now we have to do it in place. That is very important. Okay, that's what makes this question of a medium complexity. So what we have to do is, we will take one pointer, we will call it as a j pointer, right? So j pointer will point here in the beginning, and for an I pointer will go from left to right in this array. I pointer will go from left to right. And for each of the number, what we will do, we will keep checking. We will start from this point, okay, this point we will start, and we will start checking this number with this previous uh, two number basically. So one we will compare with this 0, so they are different. It means that this 0 we definitely will keep, right? Because first two numbers you can definitely keep, there is no problem, correct? Okay, this one, now 1 is different than 0, so I will keep 1 here. Now I will go forward, right? My I will go here, and my j will point here now, right? Sorry, my j will point here now, right? J will point here, it's pointing, okay. Now this one I will compare to this 0. Always go uh, two points backward, right? 2 points backward. So now this one is the index is 3 here, so I will go and I will check index 1, right? This is index 1, so they are different, so I will keep it here 1, okay. Now my j pointer will go here, right? Okay, this is now interesting now, okay. So now I am here, my I pointer is here, right? I pointer comes here. I will now compare with this one, right? So right now my index is 4, I am comparing it with index 2, correct? So they are same basically. So I will not move my j pointer. My j pointer will still point here, okay? J pointer will point here, and I pointer moves forward. Now I pointer goes to index 5. This one will be compared with this one, so they are same basically. So I will not move my j pointer. My I pointer will move forward basically, correct? So I pointer comes here, okay, at number 6 index. Now this 2 and this one I'll compare, right? So they are different. It means that I will put that 2 here now, and I will move my j pointer here, right? Okay, so j pointer goes here. Now I will compare this 3 with this one, they are different, so I will put 3 here, right? And then I will move my j pointer forward, correct? Then this 3 I will compare with these 2, and they are different, so I'll put this 3 here and move my j pointer forward. So now I am at the end of the array. It means that I am done. I will wherever my j pointer will tell me how many elements I already have in this array basically, correct? So why we are comparing like this? Because we can have maximum 2 unique numbers. That's why we are actually comparing any index. For example, index 8 with index 6. We compare 2 minus 2 basically, because we can have maximum 2 unique elements. That is why, right? You can see here, right? Each unique element appears at most twice, right? That's why. So you understood why we are comparing like this, right? Okay, that's great. So now you understood this logic clearly, I hope. So this is kind of a 2-pointer approach. So one pointer I will go forward in the original array, and one pointer j will to keep track of where I want to put that number basically, correct? As I shown you, and we will update the original array itself basically. So we are actually doing this in place. We have not used any other data structure, no array, nothing basically, correct? So it is called as an in-place solution. It means that we have not used any extra memory here. Okay, so I hope it's clear to you now how this solution will work and why we have done it. Because maximum 2 elements, right, which are duplicates. That's why every index you will go and subtract 2 from that index. So 8 minus 2 you will do, and you will check the element at index 6 and compare that with index 6. So 3 you will compare with this 2, for example, correct? This one you will compare with this one basically, correct? And then you will understand that these are same. It means that these are duplicates actually. So you want to remove these two. You want to remove this, right? That's why. Okay, so now all good. So we'll go to the Java code now. I'll show you there more. So remove duplicates is what we are implementing. This method takes nums as an array, and we will first calculate the length of the nums array in n. If n is less than equal to 2, you don't have to do anything, just return n. If you have only 2 or less than 2 elements, right? So just that quick check. After that you will put your j pointer at a second position, correct? J pointer will start from this position, which is second index, correct? Because it doesn't matter for these two index, right? Even if you have two duplicates, it doesn't matter there. Okay, after that I is equal to 2, I is less than n I plus plus. So now you will start moving your I pointer from number 2 position onward, and you will start checking nums of I with nums of j minus 2. Very, very important. If they are different, then you want to take that number. Basically they are different, then you want to take it, correct? Then you will say nums of j is equal to nums of I and j plus plus. Exactly what I explained you here, correct? Exactly same thing. So let me remove all these colors. So what I mean to say is, when you are comparing the numbers, right? So your j pointer, you will start from here actually, right? Not from here. So j pointer will start from here, and here you will compare this value with its previous value, means minus 2 basically, right? So if it is index 2, you will compare it with index 0, right? And if they are different, you will place that value here. So that is what exactly we are doing here, right? Nums of I is not equal to nums of j minus 2, then you put nums of j is equal to nums of I, and your j pointer will move forward. So j pointer will move forward here basically, correct? Next time. So you will keep doing this in the for loop until the end of the array. At the end, you have to just return the j, and j will tell you how many elements are there in the array, right? So in this case there will be 7 elements, so you will just return 7 here, right? So this is how the solution works. So let us talk about the algorithmic time complexity for this code. So the time complexity for this code is going to be order of n, because we are still iterating through that loop in this for loop, right? So it makes this solution order of n on time basically, right? And on the space side, this solution is order of 1. This is also called as constant by many people, because we did not really use any data structure. We are doing an in-place replacement on the same array, correct? So this is how the solution looks like. Now let us give it a run and make sure it works on the test cases. So as you can see, we are getting correct answer here, right? We are getting correct answer. We'll submit this code now to the Leetcode. Make sure this code is getting accepted by the Leetcode. And as you can see, the code got accepted by the Leetcode. It's 100% on the performance, which is a very, very good solution to solve this coding problem 80. Remove duplicates from sorted array 2. So this is what I wanted to discuss with you in today's session. So I hope this example and this explanation help you understand this problem in an easier and better way. And if it did, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription is very valuable and important for us. It really helps and supports this channel. Here we create videos to help others in their coding and Java interviews by showing them how to solve different problems. There are more than 500 different varieties of solved coding problems are available, which are many of them are fan coding questions asked by big tech companies in their interviews about graphs, matrices, binary search trees, binary trees. Different data structures related questions such as stacks, queues, priority queues, min heap, max heap, dynamic programming, recursion, as well as memoization questions are also available on this channel for you. So don't forget to check out the important playlist that I said. Those are going to give you really good preparation for your interview rounds. If you are a Java developer consultant looking for telephonic interviews questions, then there are videos that discusses those questions and how to answer them as well, available for you on this channel. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, uh, keep trying different techniques of problem solving. And thanks for watching this video, and have a great day ahead.